Hi, welcome to the Shiko Math Practice Lab, Learning Through Practicing. And this is the second practice for the related rate problems. We did the video on the practice number 1. That's what I call this level 1 related rate problems. Are very, very simple related rate, and it's very easy to set up. And now for this video, we're going to do 6 extra problems here, and they're going to be a little bit harder, and it's not too bad than our level 2. So let's take a look at what type of the problems we are going to take a look here. Okay, so here, let's see here. Okay, so for the practice number 2, so this is the first 3 sets, and this is the remaining 3. So we total going to do 6 problems here. Okay, so now let's go ahead and start here. Okay, so in here, they said a boat. Okay, so a boat is pulling into a dock and with a rope and attached to the bow of the boat and passing through a pulley. Okay, on the dock, that is 1 meter higher than the bows of the boat. So if rope is pulled in at the rate of the 1 meter per second, how fast is the boat approach the dock when it is 8 meters away from the dock? So remember when we talk about the related rate, so what is the step number 1? We always want to say, we say graph it, right? So the graph it here, right? So here, this is my, well, let's try to do a picture here. So, okay, so this is my boat, all right? I hope that my graphic is good. All right, so then this is the pulley, right? So this pulley here is like, then I have a rope here, try to pull in. And then they tell us here, this is the pulley is once, right? And now this is my rope here. Okay, so the step number 2, remember we say, let's try to find all the known variables and unknown variables here. All right, so here if this is 1, okay, so I can assume this one is x here, right? So this one, the rope here is y here. All right, so they say the rope was pulled in at the 1 meter per second here, right? So this is the rope was pulled in at 1 meter per second. So now if in here I say y is rope, that means dy dt is equal to, because you go in, all right? So that's why, that means you go to, like you pull that in here, so you're going to closer and closer. So this will be negative 1 here, right? So that's why, be careful. That's when you set it, that means this is negative 1 here. Okay, and then what is the, we have this 1 meter higher, we know. And then we said we want to find out how fast is the boat approach to the deck. So we want to find the dx dt, right? So this is we want to find. And then what is given also? The x equal to 8, when the x equal to 8, and what is the, that's the given. So how fast is the boat approach to, the dock here. And then we also know this, the pulleys here, this is a fixed constants, right? So we'll put on the graph. All right, so remember then the number 3, step number 3 is try to find a relation for all those variables. And this one is pretty easy. So we say is y squared is equal to what? X squared plus 1. Those are the Pythagorean series, right? Then what is number 4 here? We said after you find the number 3, number 4 is pretty easy. You take the derivative of both sides, but make sure you use the chain rule because it is the function of the t, right? Both of them is a function of the t. So y squared, I will have a 2y, and then here is what? dy dt. And what is here? This is 2x, and I have a dx dt, right? Okay, so now remember I want to find the dx dt. So I want to find the dx dt. So what will be that will be the 2x. This is 2y dy dt. Okay, so here the 2 and the 2 cancel, that's good. And the dy dt, you know, is given. So this one's here is a -1. So that is good. X is given. X is what? Is 8, right? Now I need to find the y's here. So how do I find the y's here? I need to use the Pythagorean theory, right? So I know y squared is equal to the x squared plus 1. So it's 64 plus 1, so it's 65. So y will be just the square roots of the 65. So now I have everything here. So this is 65 here, square roots of the 65. So now my final answer is here. I'll be able to find it. So I know that dx dt is equal to the square roots of the 65 times -1 divided by 8. Okay, so then you will get the answer is approximately to -1.01 meter per second, right? So in here, this negative sign also makes sense, right? Because you're pointing, you know, from to this directions, right? It's getting shorter and shorter, right? So that's why it's negative, just like this one's here, you're pointing the rope in this one. So that's why you need to put the negative one. So this one is kind of makes sense also. All right, so this one is kind of a pretty easy ones here, okay? So now let's take a look at the second ones here. The second ones here is okay, let's see here. They say the water is leaking out of an inverted conic tank at a rate of 10,000 centimeters cube per minute. At the same time, the water is being pumped into the tank at a constant rate here, okay? Then the tank, you know, the tank has a height of 6 meters and the diameter on the top is 4 meters, okay? If the water level is rising at the rate of the 20 centimeter per minute, then when the height of the water is 2 meters, find the rate of the water is being pumped in. This is such a classical related rate problems, and you know, it's a very popular, like a lot of like a test problem because it's use a lot of good information, right? So let's try, like we say, let's try to graph it, right? So this is a conical tank. So it's something like this. It's kind of like an ice cream cone, okay? So then let's mark the things we know. They said the diameter is 4 meters. So that means that the radius is what? The radius, this is 2, right? Now, also let's say the height. So this is 2 meters, right? And also the height is from here to here, right? So this is the height. Also, the problem given us, the height is what? 6 meters. Right? So this is 2 meters, and this is 6 meters here. Okay, so now let's say, okay, so the water coming in and get out is here, right? So we said when the water level is rising at the rate of 20 centimeter and the height is 2 meters. Okay, so now let's see here. So we have here. So if this is what is the water levels here, right? So we say this variable, we call it is the height, right? So the height will change here. And then we have another variables here because if water level is in here, then I have another levels, another variable is R, right? So it's radius whenever the water sits there. Okay, now let's see how do we set it, right? Okay, so let's put all the variable we know. So we said we pump in the water in the tank in a constant rate. Okay, so let's say here C is the rate. So the rate of the water pumping, okay? Okay, so C is the rate of the water pumping in. And also the water going out at 10,000 centimeter cube. all right? So now I know that at any moment, the volumes here, right? So when the dV dt, that means the volume of this tank, see here, going to change what? What is the change of the volumes here? Will be C minus 10,000, right? So you have how much come in, you minus how much get pumped out, see here, right? Also, what is the other things we have? We say, oh, the water level is 20 centimeter per minute here. That means I know my dH dt. That's how high the water go. dH dt is what? Is 20 centimeter per minute here. All right. So that's the dH dt here. Okay. So now, and now the next thing here is, so we say, okay, so what is the relations we have? We said, okay, the relation here we have is the volumes, right? So the volume is, because it is a conic volume, so it's 1/3 pi r square and h here, okay? So it's a pi r square at h. And the key things for this province here is I don't know. There's no information was given for the r. So if the r is here, right? So we need to find what is the r values here. How is it related to the h values here, right? So think about here. So this for this conic, right? Okay. So this is my conic things here. And then if you kind of cross sections here, I want to do if you kind of cut it, right? So if you cut it this way, you cut it this way, right? So what you see here, so this green one is what? Is triangles here, right? So this is a triangle, and this is my R. And I know this thing is fixed. The top of this conic is fixed, is 2, correct? Okay, and we know the height here, this one is fixed. This is 6, right? Then this is a variable. This is the height. So now I'm going to use a similar triangle. So what is my similar triangle? Is this small yellow triangle? We used this before, right? And I want to compare to this big purple triangles here, right? So they are similar. So I know if they are similar, then the ratio will be the same. That means the base compare with the base, right? So you say the 2 compared to R is will be equal to the height compare with the height. So the height is 6, and here is H here, all right? So now you will see here, so you will say, let's flip it. So it's R over 2 is equal to the H over 6. So what is the R? R is equal to the 2 times H over 6 equal to the H over 3 here. So I know there's a relation of the R and the H here. So now I can replace it. So this is 1/3 pi. What is R again? So it's 3H to the square times H here. All right, so now that's why you will get a pi. 3 squared 3, so it's 27 h to the what? H to the cube. Okay, so this step, okay, so be very careful. This is the step, is kind of a little bit different than what we did in the first videos, right? The basic one. So this one is take an extra step. So you know the H is what we're looking for, right? So, like right now, so because of, because of this, right? So I don't have the R value. They did not give us any R information. So that's why I need to find the relation for the R. Oh, so in here, so we want to find the rate of the, we want to find the rate of the water pumping to the R. So we want to find the C. See, this is what we want to find, all right? Okay, so the number 3 is here. So this extra step, so it's very careful. Okay, so number 4 is here. Let's take the derivative of both sides. So the dv dt is equal to pi over 27, 3, the h squared dh dt. Okay, so this will give me pi over 9 h squared dh dt. Okay, now I have all the values here. That's pretty cool, right? So here the dv dt, so the dv dt we just give here, right? So the dv dt, so this is c, so this is c minus 10,000, okay? And it's equal to pi over 9. So what is the h there? Let's say when the height is 2 meters here, right? So be very careful. Meter to centimeter is 200, right? To the square. And then the dh dt. What is the dh dt here? It's 20 centimeters here. Be careful. You need to careful about the units here. Okay. And then in here, you will say the C, just to try to solve this. 10,000 is like 4,000, 40,000 times 20 times pi. So this is kind of like a pi times a, think 1, 2, 3, 4, 5, right? Okay, and to the 9. So that's why you can solve for C. C will be very close to the 289, 253 centimeter cube per minute. Okay. All right, so that is how do we solve this type of problem. So the key things here is this. Like I said, this is such a very, very classical related rate problems here. And almost like all the teachers, they love to give this type of the problem on the tests here, okay? Okay, so the next problem is here. Okay, so next one, they say a kite is 100 feet above the ground moves horizontally at a rate is 8 feet per second. At what rate is the angle between the string and the horizontal decrease when 2,000 feet string has been let out? Okay, so this one is not too bad. Okay, so this one's here, number 1, let's do the graph here, right? Okay, so here you are standing here playing the kite, right? So here's the kite here, okay? So the kite, let's do this kite, right? So I have something, right? Look like a bug. Okay, that's good. So this is the kite, right? So we said this is the, let's try to mark here. So this is the 100 feet, right? So this is a 100 feet above the ground. And you are standing here. So let's say here, this is X and this is Y. And I'm looking for the angle theta here. Okay, now let's try to put our numbers here. Okay, so number 2, after we did the graph here, so let's see what we want to find. So a kite is 100 feet above the ground. So here it is here, right? And it's moving at a speed 8 feet per second here. So that means that moving this way. So what I have here, I have dx dt, right? So the dx dt is moving away. So it's go this way. So it's 8 feet per second here. And I want to find the rate of the angle between. So I want to find the d theta dt. This is what we want to find. And then they also say when is 200 feet of the string has been letting out. Okay, so 200 feet of the string has been letting out. So that means this is the strings, right? So that means y is 200 here. Okay, all right. So now let's try to set these equations here. So the step number 3 is here. All right, so here, so we know this is the x and the 100s, right? So I know tangent is opposite over adjacent. So I can say the cotangent theta is adjacent over over the opposite. So the x is equal to the 100 cotangent theta. Okay, just, now after that, all right, so now the next things here we say, okay, after you find it, it's easy. So I say the dx dt is equal to the 100. So what is the cotangent derivative? It's negative cosecant square theta, right? And don't forget with the d theta dt here. Okay, so now the d theta dt is here. Okay, so now we want to find the d theta dt's, right? So the d theta dt is equal to negative 100 cosecant square theta dx dt. Am I right? Yes. Okay. So now in here, then we can put this is dx dt. The negative 100 cosecant really is sine square theta, right? Okay, dx dt. All right, so dx dt is what? Is 8, right? And then the only thing I have is the sine theta here, right? So I want to find the sine theta. So I know the y here is what? Y is 200, right? Okay, so the sine is opposite over hypotenuse, right? So in here, I know the sine theta is what? Opposite over hypotenuse, so it's what? It's 1/2. Then you need to have a squares, right? So last is, okay, so now I have all the values here. So what I have here, I have a negative 100 here, 8, and then I have 1/2 to the what? To the square. And then if you put it into the calculation, so you will calculate yourself is 1/50 radians per second, right? Because there's no units, so we know this is radians here. Okay, and so this one is not too hard. Okay, so let's take a look at the next ones here. The next one, we did a similar problem in our lectures series here. So let's take a look at these ones here. So these ones here, let's say at the top of the ladder sliding down a vertical wall at a rate of 0.15 meter per second. At the moment when the bottom of the ladder, is 3 meters from the wall, it slide away from the wall at a rate of 0.2 meter per second. How long is the ladder? So it's a little bit different. So in our lecture series problem, we given the ladder. So right now we want to find it. Okay, so let's do the pictures here. So let's say here, this is the letters, right? So I use L to represent, and I know the letter is fixed numbers, right? Okay, so now I can say this is the X here, this is Y here. Okay, now let's do the same things here. Put all the information down to see what is given, what is not given. Okay, so this is the first ones here. Let's say the ladder sliding down, right, at a vertical wall at the 0.15 meters per second here. What's that mean? That means the dy dt, because going down, so it's negative, so it's a negative 0.15, okay? And the dx dt, right? So the dx dt is sliding away, so it's sliding this way, it's getting bigger. So the x is getting bigger, right? So now I know the dx dt is what? So the dx dt is equal to the what? 0.2, right? So dx dt equal to the 0.2. And so we use this information. And the bottom of the ladder is 3 meters from the wall. So the x equal to what? X equal to 3 here. Okay. And what do we want to find? We want to find the what? We want to find the letters here. Okay. So now after this all information, let's take a look at step number 3. We want to combine those things. This one obviously is a Pythagorean series. So I would say L squared is equal to x squared plus y squared here. Okay. And now I'm going to take the derivative of both sides. So this one's here will be 0 because the ladder is fixed, right? So ladder, the length of the ladder is fixed. Now here, this is 2x dx dt, correct? And then plus 2y dy dt here. Okay, so in here it's okay, so I can see here, so this is the negative 2x dx dt is equal to negative positive 2y dy dt. So let's simplify this. So 2 and 2 can cancel. Let's see what the value we have. X here, let's say x is 3. Dx dt, this one given is 0.02. And this one, dy dt is also given is 0.15, negative 0.15. Oh, the things I don't have is y's here, right? So I can say y is equal to the dy dt, and then this is negative x dx dt, right? So dy dt is 0.15, negative 0.15. So this is negative 3 times 0.2. All right. Okay, so now if you put it into the calculator, you will get what? Y equal to what? Y equal to 4, right? Okay, so this is our step number 4. Plug that in. So last step here. So because now you get the y equal to 4, x equal to 3. So I can use the Pythagorean series. 4 square plus 3 square is 25. So the letter is what? So letter is the 5 meters, right? Okay, so that will be our answers here. Okay. All right, so the next one's here. Okay, so the next one, let's say 2 sides of triangles have a length of 12 meter and 15 meter. The angle between them is increasing at a rate of 2 degrees per minute. How fast is the length of the third side increased? Okay, so this one is a little bit more complicated. It's because we have a degree, we need to change it to the radians. Then we also need to use a special trig function laws here, right? So let's try to graph it first. So here, this thing, this side is 12, this side is 15, right? So this is my third side. Okay, so this is my third side. And then this is my angles between them here. All right, so let's see here. Okay, so let's see, how do we find the values here? Okay, so I guess this is all given. I will say this side is x here, right? And then let's take a look at what is the other information is given. The given is t theta tt. This is 2 degrees per minute. Yep, okay. And now what do we want to find? We want to find the x values here. Okay, so now the step number 3 for this one's here, the step number 3, probably if you don't remember the trigger, that probably will be a little bit difficult. So now I'm going to use the law of the cosines here, all right? So this is the x squared. So I'm going to use the law of cosine. So x squared, all right, is equal to the two side square. So it's 12 square plus 15 square and minus 2ab. So minus 2 times 12 times 15 times the cosine theta. Correct? Right. So now after that, I can take the derivative of both sides here. So I have to take this is a 2x dx dt is equal to all this 12 square, 15 square is a constant. Cosine will become what? Negative sign. So here will be the 2 times 12 times 15 sine theta d theta dt here. All right. So we know the d theta dt here, right? And then, okay, so so they said how fast is the length of the third increase when the angle between them is 60. Okay, we forgot to write this information here. So the theta is 60 here. Right. Okay, so we want to see the 12 meters. Okay, so now, okay, so we want to see how fast the dx dt is, right? So what do we want to find? How fast is the length of the dx in dt? Okay, so we did not write this one. We don't want to find the length of that. We want to find how fast. So we want to find is the dx dt here. Okay, so now I'm going to find the dx dt. So the dx dt, it will be the 2x. And this is what? This is 30 times 12. So it's 420, right? 30 times 12. 30 times 12. Oh, 360, huh? So it's 360. My basic algebra was, okay, so it's 360. Okay, so this is 360 sine, what is the theta here? 60 degrees, right? And d theta dt. Okay, so let's see here. We can put the value. Sine 60 is what? Is the sine 60 degrees. What is the sine 60 degrees? Is the square root of the 3/2, right? And now I'm going to find the d theta dt. This given here is 2. But I know when I do the multiplication, I cannot have a degree. So I need to change to the what? Radians here. Okay. So the one I'm going to change to the radians here. So this is a good ones because you use a lot of information here. So the 2 degrees, how do I change radians here? 2 degrees is the pi over what? 90 radians, right? That's what in your tricks here. So you learn how to change the degrees to the radians here. So that is the first one. We need to be careful here, right? When you times. So now I know, okay, so that's good. I have this value is what? I have this value is pi over 90. Almost there. I still need to have what? I still need to have this x values here, right? So how do I find these x values here? Okay, now I can use the law of the cosine. So I know the x squared is equal to 12 squared plus 15 squared minus 2 times 12 times 15. Now the cosine 60 degrees. That's right. Okay. So now the cosine. So now if you do that, if you plug that one in and you plug all the value in, and then the x will just be the square roots. I think it's 180, 9. Okay, so you can change that. It's 3 of the square roots of 21. All right, so that's what is the x value. Right now, finally, I can plug in. So I know everything here. So this is 3 of square roots of 21. Okay, so finally, I can plug in all the numbers. So this is 360 times the square root of the 3 over 2, and the times the pi over 90, and the 2 times the 3 square roots of 21 here. So if you simplify it, so it will give you something like a pointer 396, approximately to the point 396 meter per second per minute. Okay, so this one is a little hard. The why is a little hard here. The few things, right? The first things you, of course, you need to know the law of cosine, like we talked before. The step number 3, sometimes the hardest one. You want to find this relation. Then the second hardest here is you cannot times the 2. You cannot times the degrees here. So that's why, how do you change the degrees to the, to the radius? Okay, so that's the another ones here. We need to be careful here. Okay, let's take a look at our last problem here. This one is also, it's very, very classical kind of related rate problem. Okay, so they say a trough is 10 feet long and its end have the shape of isosceles triangles that are 3 feet across at the top and have a height of 1 feet. If the trough is being filled with water at a rate 12 feet cube per minute, how fast is the water level rising when the water is 6-inch deep? Okay. All right. So let's see here. So the first thing here is we need to know how to do the pictures here, right? So let's try to write a picture. Okay, let's draw the pictures here. I hope that I can draw this prettier. This is very difficult shapes here, right? So let me do here. I hope that I can do it. All right, so here. All right, so here. All right, so this is the triangle trough here. Hey, okay, so here the okay, so basically you can see what that means here, right? Okay, so here I have here, I have here. Wow, so I guess, okay, so this is kind of like the triangles here. It's kind of like a triangle prism. Gee, I have a hard time to draw these ones here. Right? So I guess you can see that it's kind of like a triangle prism here, right? So it's kind of like this is a triangles here, and this is triangles, and so you can see it's a triangle shaped, right, all the way. I don't know. I think I did not do a good job of drawing, and I really have a hard time to draw this. I guess draw like in the okay, so something like that, right? So so I think here maybe oops, don't kill all of that. All right, so here, okay, so. Anyway, so you can visualize that. Okay, so sorry, I cannot draw very well here. All right. So now let's mark some things here we know. So the trough is 10 feet long. So that means from here to here, this is a 10, right? And also it's isosceles triangle. So that means here past this is 3 feet. And the height here is 1. Okay. And the trout is filling with the water at a rate of 12 feet per minute here. So I want to see what is how fast the water level rise when it is 6 inches here. So, right, so this is the water level H here. Okay, So now let's see here. Let's write it down, the things we know. So the H is so the water is filling the rate 12 feet cube. So I know the dV dt, the volume is going up at 12. Correct? Okay, so the water is going up at the 12. And what I want to find here, I want to find dH dTs, right? So this is what I want to find, dH dt when the water is 6 inch deep. So 6 inches is 0.5 here. Okay, so all the others are constants. Good. Let's see here. Okay, now number 3 is here. I want to find the dV dTs, right? So I will find the volumes, right? Since this, since this is the like a triangle prisms here. So basically it's the base times the height. We know the base times the height is the area, right? The base times the height is the area of this triangle, right? So then times 1/2, then you times the height, you times the length, that would be the volumes, right? So I know the volume for this trough here is 1/2 base times the height, right? So it's base times the height, then times the 10. So this is the 5 BH. All right, so for anything, so if the, if your height is here is, if you filling this much water, then what is the volume for at this levels, right? So we know the H, we don't know what, we don't know B. Okay, so this is the similar like we did for the conic tank, right? So now we need to find the B. So you take a look, the cross section is isosceles triangle. We use this relation, the similar triangle relations, a lot all the time. So this one's here, the top, this is 3, right? And then we know the height here. So this one's here is 1. Right, so this triangles here. And then now if I have a height here, so this is the height, is the H here. I want to find this is the base here. So it's just like we did before, right? So we have this big triangle here, right? And this triangle is similar to this small triangles here. So now let's use the ratios, right? So we know the 3, right? So 3 compared to the height will be equal to the B compared to what? Compared to the H's here. So I know B is equal to what? B is equal to 3H. So that's good. So the B equal to 3H, I will say B. So B is equal to the 3H, right? So then times H. So I'm just replace the B with the 3H. So this will be what? 15H squared. Now number 4 is here. Okay, finally we have a V and H. I can take the derivative of both sides. So I will say dV dt is equal to 30H dH dt. Now I plug in all the values. The dV dt is 12, 30, so it's 30. So what is the H? Is 6 inches, so it's 1/2. I'm looking for the dH dt, right? So the dH dt, so you solve it, the dH dt will just be what? 12 over 15, so it's 4 over 3 over 4 over 5, right? So it's 4/5. Okay, so I know the water going to increase in the 4/5 feet per minute here. All right, so this is the one, is kind of the similar difficulty as the one like the conic tanks, right? So the idea is very similar. You want to use the similar triangles to find the extra variables, which the problem did not tell you here. All right. Okay, that's it. We have a practice about like the 13 provinces in the related rate. I think you should get a very good idea how do we do some simple related rate province, and then it's kind of, it can become very complicated, but we did a couple very complicated one, and I think, as long as you follow the steps, right? You do the graph and you write down what you know and you find the relations and then you substitute, right? And take the derivatives here. All right, that's it. And nice talk to you about the related rate provinces, fun topics here, right? Okay, and talk to you next. Okay, bye-bye.